Today we are going to solve Cambridge IGCSE paper 4, which is theory paper, and the paper code is 0625/41, and it's a May-June 2023 paper. So let's start off with our question number 1, and it states that figure 1.1 shows a straight section of river where the water is flowing from right to left at the speed of 0.5 meter per second. A swimmer starts at point P and swims at a constant speed of 0.72 meter per second relative to the water and at a right angle to the current. Determine relative to the river bank both magnitude and direction of the swimmer velocity. So over here, what you need to do is you have to find out. The swimmer is moving in this direction, which is around 0.72. This is the velocity of the swimmer, and the current is moving in this direction, and this is going to be 0.54. So if you apply the right angle rule or Pythagoras theorem, so you can get this answer. It's going to be 0.54 square plus 0.72 square root, and this will give you 0.9 meter per second. So this is going to be 0.9 meter per second, and if you want to find out the direction, so again you have to apply tan theta is perpendicular over. So if you apply this formula, tan theta equals to perpendicular over tail painted black base, so perpendicular is 0.72, and this is going to be divided by the base 0.54. If you apply the formula, this will end up 53.13. so this is going to be two significant figures. So this is the direction of their velocity. Okay, now moving to the next question. After 1.5 minutes, the swimmer reaches point Q. Calculate the distance between P and Q. Okay, so what you need to do is you have the magnitude of the velocity over here, and where speed is equals to distance over time. So speed times time will give you distance. So if you have the speed, which is 0.9 times 1.5 minutes, is going to be 90 seconds. You have to convert into this, so it's going to be 81 meters. And when the swimmer is crossing the river, his action produces a constant forward force on his body. Explain why he moves at a constant speed. Because of the friction or resistance force, friction or resistive force, or you can say that both forces are balanced, or you can say no resultant force. Figure 2.1 shows a motorcyclist accelerating along a straight horizontal section of track. The motorcyclist and the motorcycles have the combined mass of 240 kg on the straight horizontal section of the track. The motorcyclist accelerates from rest to. This is going to be the acceleration. The motorcyclist reach the end of the straight section in 5.3 seconds. Calculate the speed of the motorcyclist at the end of straight section. So for this, you need to find out, you have acceleration is given, so we will apply this formula over here, delta V over T, but we need to find out the speed, so it's going to be acceleration times time. So this is going to be 7.2 times 5.3, which is going to be 38 meter per second. So this is your final answer. Now calculate the resultant force on the motorcyclist and motorcycle on the straight section track. So again, F is equals to ma, mass is given, which is 240, and acceleration is 7.2. So you multiply this thing and you will end up with 700 newtons. So this is going to be your final answer. At the end of the straight section, the track remains horizontal but bends to the right, as shown in figure 2.1. Okay, we have seen this thing in the figure. Now there is a bend over here. And when the motorcyclist reaches the bend, she travels around the bend in a circular path at a constant speed. Velocity is a vector quantity. State how vector quantity differs from scalar quantity. So, vector quantity has direction and magnitude, whereas the scalar quantity has only the magnitude. Describe what happens to the velocity of the motorcyclist as he travels around the bend at constant speeds. So what will happen? The velocity is going to change. Velocity changes as the direction of motion or direction of velocity changes. Velocity changes. This is happens in circular motion. Okay, explain why there must be a resultant force on a motorcyclist as he travels around the bend, because we know that there is acceleration is directly proportional to force, and because of acceleration, the change in velocity or change in direction. So this is the reason, change of direction. There is resultant force on the motorcyclist when he is moving in a circular track. A rubber balloon is inflated with helium and sealed so that no helium escapes. The balloon is positioned immediately below the ceiling in a room. Heaters are switched on and the temperature of the air in the room increases. When the heaters are first switched on, the temperature of air immediately below the ceiling increases more quickly than the temperature of air in the rest of the room. Explain why this is going to happen. Because of hot air, and that hot air rises up, and you can also mention hot air is less dense. Okay, the temperature of the helium in the balloon increases as the rubber stretches. The volume occupied by helium increases. State what happens to the motion of the helium particles as the temperature increases. So your kinetic energy increases, your velocity of the molecules increases, their momentum increase, their collision is increased, there will be more force. Okay, as the rubber stretches out and the volume of the helium increases, the pressure of the helium remains constant. Explain in terms of particles of helium how pressure of helium remains constant. So now you see this thing, if there is more pressure, and there will be more pressure because of high temperature, and the molecules, their momentum will be again more, their kinetic energy is also going to be more, volume is going to increase, and this means that the collision is going to collision. So you guys can write these statements, and obviously if the area is going to increase, the collision is going to decrease, and pressure is inversely proportional to area, and the effect of area is going to cancel out the effect of rise in temperature. Okay, next question states that a student investigates the efficiency of a filament lamp in figure 4.1, shows the filament lamp with its glass bulb immersed in water in a beaker. The readings on the thermometer in the water is 19 degrees Celsius. Only the glass of the lamp is in contact with the water and electrical connections are completely insulated. The lamp is switched on. At the end of the experiment, the temperature of the water is this, the mass of the water in the beaker is this, and the specific heat capacity of water is there. So you have to prove that, or you have to show that the internal energy of the water is there. So applying the specific heat capacity formula, so this is going to be this one. So mass is 600 divided by 1000, because you need to convert that into kilograms, and then you have to put the values of specific heat capacity and the change in temperature, and then you will get the required answer. In the experiment, the lamp is switched on for 500 seconds. The power supply to the filament lamp is 13 watts. The useful energy from the lamp is transferred as light. The energy that increases the temperature of the water is wasted energy. Determine the maximum possible efficiency of the filament. So what you have to do is first you have to find out the energy is going to be power times 13 into 500 is going to be 6500 joules, and now you have to find out the useful energy. So basically that was the total energy. Useful energy is equals to 650 minus 6300. This energy we got from this value, so it's going to be 200. So now we have to find out the efficiency. So it's going to be 200 divided by 65 into 100. So this is going to be 3.1%. So this is the required answer for this question. The efficiency of lamp is less than the value determined in A2. This is because suggest one of the reasons. This is because the temperature change, and that temperature change is due to thermal energy losses. Thermal energy losses. And then it's you can also write it down that the thermal energy is transferred to surrounding. Energy is transferred to surroundings. So basically the temperature is going to be changed, and due to the thermal energy losses it's not going to perform very well. Okay, moving to the next question, and it states that figure 5.1 shows a block ABCD made up of glass that has a refractive index of 1.5. The block has one curved side AB and three sides BC, CD, and D, AE. So there are the right angles at C and D. The curved side AB is 1/4 of the circumference of the a circle that has a center at point P. A ray of monochromatic light enters the block through the curved side AB and strikes side BC at P. Some light emerges into the air and some is reflected. State what is meant by monochromatic light. So monochromatic lights are light with a single frequency. Light with a single frequency. It can be electromagnetic radiations as well. Explain why the ray of light does not change direction when it enters the block through the side AB. So when it is going to enter from the side AB, is this light is not refracting. So why he is asking this? It's because the angle of incidence is equals to angle of incidence equals to 0, or you can say angle of reflection is 0. So means that there is not going to be no refraction, or you can say that when this light is perpendicular to the medium, when the light ray is making a 90-degree angle with the surface or boundary of the medium, so it's not going to refract. Okay, show that the critical angle C of the glass refractive index is 1.5 is 40. So simple formula is psi is this. C equals to critical angle equals to sine inverse of 1 over n is equals to 1.5. So you put this value into the calculator and you will get your answer 42 degrees. Figure 5.1 shows that the angle between the ray of light and the line AP is theta, where the line AP is at a right angle to side BC. Angle theta increases to 45. State and explain what happens to the light that strikes P. So all the light is going to be reflected because all the light is reflected. Secondly, angle of incidence is greater than the critical angle, so it means that all the light is going to be reflected rather than refracted. Okay, when theta is 45 degrees, the reflected ray light strikes side CD. Describe what happens when this reflected light strikes side CD. So, what will happen if you see the figure? All the light is going to be reflected because the reflected ray at 90 degree is basically the reflected ray is at 90 degree to incident ray, or you can say the reflected ray is parallel to the original ray. So, you can write any of the statement for 1 marker question. A mobile phone, cell phone network use microwave frequency 1.9 into 10 to the power 9 hertz to transmit and receive the signal. The speed of this microwave is this. Calculate the wavelength of the microwave. So we have this formula V is equals to f lambda, and then we are going to solve this question for lambda. So we put the values over for V and so we put the values of V, and that is going to be 3 into 10 to the power 8, and on the value of frequency. So you put this into the calculator and you will get 0.16 meter. State two reasons why microwaves are used for mobile phone, cell phone signals. So first of all, one is this that it only needs short antennas to transmit, and it can penetrate through walls. So these are the two reasons for this question. Let's move to the next question, and it states that all mobile phone network use digital signals to communicate with the phone. Describe with the aid of diagram how digital signals differs from analog. So, digital signals are those signals which have zeros and ones, or you can say high and low values, and whereas the analogs are continuous signals like a sinusoidal wave, and it varies over ranges. State two advantages of using digital signal rather than analog. So, they are faster for transmission, they are good for this transmission, faster transmission rate. Second is signal transmitted is signal transmission over long distances, or they have more range, or you can say higher range. Then as noise can easily be removed, and then a signal can be regenerated. So out of these four, signals can be regenerated. So out of these four, you can write any of the two. Figure 7.1 shows a circuit that contains a battery, a switch, a voltmeter, and 340 ohms resistors R1, R2, and R3. The switch is open and the resistor R1 and R2 forms a potential divider. Describe what is meant by potential divider. So basically, potential divider splits, divide, or shares the EMF, voltage, potential difference, or you can write it down. Potential divider shares the EMF in proportion to the resistors. The reading on the voltmeter is 7.5 volts. Calculate the electromotive force. So, whatever the battery has the voltage. Okay, 7.5 volts. Okay, let me check. Okay, the reading on the voltmeter is 7.5 volts. Calculate the electromotive force EMF of the battery. So it's going to be 15 volts because it's going to be the twice. Half of it is going to be divided over here because this is the reading over here. So the half of it is going to be over here. So you have to add them and then you will get that. The switch is closed. Calculate the resistance of the complete circuit. So for this you have to find out that R2 and R3 are parallel. They are parallel. So for parallel you can do the rest in peace the mnemonic for solving that question. So I will be using 40 times 40 R1 times R2 plus R1 plus R2. So this will give me 20 ohms. So 20 ohms, and then is another resistor that is 40. This is going to be 60 ohms. So the final answer will be 60 ohms because that is in series. Okay, calculate the reading on the voltmeter when the switch is closed. So you have to use R1 over R2 equals to V1 over V2 formula. So from this you can find out this V1, and this is going to be R2. Okay, now putting the values 15 times 40 divided by 60, that will give you 0 0. You will be cancelled 6 3 15 3, and this is okay. This is 2 3 the 5 are, and this is 2 the, this is 1 the, so this is going to be 10 volts. Okay, moving to the next question. The electricity supply to the town is transmitted through using high voltage cables. A transformer is in the town and has a soft iron core, and explain the principle of operation of simple iron core transformer. So I will be writing some points over here. So basically he's asking the working principle of the transformer. So obviously that's when you have a transformer over here. So in the primary coil it's going to be AC is given in the primary coil, and due to the change in magnetic field of the primary coil, there will be induced EMF in the secondary coil, and that will give you the current. So basically, what is happening? Step one, AC is will be given in the primary coil, alternating current. Then you have to the current in the primary generates the changing magnetic field, and that magnetic field will hit or you can say affect the secondary coil, and that secondary coil will induce EMF due to the changing in magnetic field. The transformer steps the supply voltage down to this. There are 450 turns in the secondary coil. Now you have to use the formula NP over NS is equals to VP over VS. So if you need to find out the number of turns in primary, so it's going to be 450 times 220 upon 333. Okay, this is going to be 1 2 3, and this is 1 2 3. So if you solve this you will end up at 3000 turns. Okay, the electrical power to the transformer by high voltage is 77. Power is given. Calculate the current. Okay, VI. So this is this, and power is what, 77 into 10 to the power 6 volts. Voltage is given in this question. Where is the voltage? Voltage is, yes, there it is. The voltage is 220,000. So divided by 220,000 will give you the current, which is going to be 350 amps or ampere. Okay, then moving to the next question, figure 9.1 represents all the particles in a neutral atom of radioactive isotopes X1. Determine the number of neutrons in this atom and explain how the answer is obtained. So there are basically 1, 2, 3, 4, 5, 6, 7. So if you count these shaded dots, so these are basically 7. And the explanation is this, that the number of electrons is equals to number of protons. White dots are protons, white dots are protons, and gray dots are neutrons. So neutron is going to be 12 minus 5, which is equals to 7. So this is your answer. Okay, the isotope X1 is a beta emitter that decays to stable isotopes X2. Describe how a nucleus X2 differs from nucleus of X1. So basically X2 has one proton greater, and in X1 it is less. One is less. One proton is less. And whereas you can also write this thing that X2 has 6 protons and 6 neutrons. Suggest why isotope X2 is stable whereas X1 is not stable, because X2 has fewer neutrons in the nucleus. So this is the reason why it is more stable. So next question is define half-life. It is basically the time taken for number of radioactive nuclei to be half, or you can say that the rate of decay to half, rate of decay of the radioactive element to become half. So that's one reason why isotopes with very short lives are especially hazardous, because they have large number of particles produces in short time, or high dose of radiation in very short interval of time. So Pluto is a dwarf planet. Figure 10.1 shows the direction of the motion of the Pluto as it follows its elliptical orbit around the Sun. Okay, this is the figure. Point X is the point in the orbit closest to the Sun, and point Y is the orbit farthest away. The orbital speed of Pluto varies as it orbits the Sun. Describe how the speed of Pluto varies as it moves from X to Y and then back to this. So obviously the speed is going to be decreased when it's moving from X to Y, and speed is going to increase when it's moving from Y to X. Okay, explain in terms of energy transfer why the speed of Pluto varies in this way. Because of the gravitational potential energy that is being converted into kinetic energy, and vice versa. You can also write down the speed is going to decrease and kinetic energy is going to also decrease. So basically total gravitational potential energy plus kinetic energy is going to be constant. So this is it. Moving to the next question. The average temperature on the surface of Pluto is 43 K. Convert the temperature value to degrees Celsius. So obviously this is an easy question that you need to know the temperature in Kelvin is equals to temperature in Celsius plus 273. So 43 plus 273 is going to be okay. Convert this temperature into this, and we need to find, okay, this is again, I'm sorry, this is temperature is given in Kelvin, so we need to redo this thing. So we need to find out the temperature in Celsius. So it's going to be what, hold on, TK minus 273 equals to TC. So this is going to be what, 43 minus 273 is going to be minus 230 degrees Celsius. So 230 degrees Celsius would be your answer. So no need to write the unit. Okay. Pluto has a white surface as shown in the figure. As Pluto rotates, the white surface alternately faces towards and away from the sun. Explain how this affects the temperature of Pluto as it rotates on its own axis. So we know that white surface is poor absorber, good reflector, or you can say poor emitter of infrared radiations, and black is what is going to be again good absorber, good emitter, and poor reflector. So if you talk about the white portion, so there will be when there is an increase in the temperature, or you can say when there is a decrease in temperature, so it's going to be facing sun, and when it's going to be the black portion, so there will be decrease in the temperature, and it's going to face away from the sun. Let me write it down for you. So basically, what I have told you is this thing: when the temperature, when the increase in temperature is less, is facing towards the sun, and when it's going to be when there is increase in temperature more, it's going to be facing away from the sun. So that's it. Thank you very much. Have a good day. Take care. Bye bye.